Today we're going to work more on solving inequalities. And because the process for solving an inequality is the same as the process for solving an equation, this will give you more practice on just the solving process. The only difference that inequalities brings is the very last flip-flop step of if you multiply or divide by a negative, then you're going to flip the sign of the inequality. But what I really want you to get in your head is it's the same process to solve an inequality as it is to solve an equation. So when we look at number 1, the very first thing that we always try and do, if possible, is to clear our fractions. So let's go ahead and multiply each of these 3 terms by the -3. Now, that brings us to the flip-flop rule. If we're multiplying or dividing by a negative number, we're also going to have to flip-flop our inequality. So we're going to go ahead and just start by multiplying each term times -3. And what that gives us is -6. Our -3's and the b's, those cancel each other out. So plus b. And then we're flipping because we multiply by a negative, so greater than or equal to -9. Okay, from here, I think it's a very simple one for you to solve, so pause your video, finish it up, and check back for the answer. Okay, it was pretty straightforward from there. Now on number 2, only real part of number 2 is just getting you used to working with decimals and answers that are fractions or decimals, either one, just working with more unusual numbers. So go ahead and work through this one, pause your video, and do the work, and then check back on the answer. Okay, there's a couple of things to point out on number 2. First, when we're just distributing a negative number, that's just distributing. It is not the same as the flip-flop rule. The flip-flop rule means we're multiplying both sides by a negative number. So the multiplying or distributing the -1.2 did not make us flip-flop. But further down, when we divided everything by 1.2, -1.2, that's what caused the flip-flop. Now, when you got this and you divided this into your calculator, you came up with like -7.6666667. I went ahead and pressed the math key and turned it into a fraction, which is a lot easier to deal with than repeating decimals. Okay, for number 3, go ahead and pause your video, do the work, and then check back for the answer. Okay, number 3 was very straightforward, just reminding you of the process of collecting all your variables on one side. I notice I wrote the answer both as a fraction and as a decimal, depending on how you wrote your final answer. Either one is perfectly fine. Okay, moving over on to number 4, it's adding another step in of combining like terms and collecting your variables on one side. So you're just practicing the process. Go ahead and work it, pause your video, and then check back for the answer. Okay, number 4 was pretty straightforward. On number 5, before you start working on it, yes, there is a fraction, but it's in the middle of a distribution problem. So you're going to have to distribute and then see if there's any fractions left to clear. So go ahead and work on it and check back for the answer. Okay, other than being able to distribute 2 times before working, there's nothing very challenging in number 5. Number 6 is asking us to graph our solution in number 1. The biggest thing to remember is, should you use an open circle or a solid closed circle? So if you can't remember that, check back on the notes from yesterday and then answer it and check the video for your answer. Okay, so the less than or equal to sign, the equal to told us to make it a closed circle. Then I went ahead and just drew a line. I'm sorry, that's a greater than or equal to sign. I went ahead and drew a line in my greater than sign, and it gave me the arrow pointing to the right. So then I just drew my arrow pointing to the right as well. Okay, something interesting is going to happen on number 5. I want you to go ahead and solve it and see if you can figure out what interesting thing happened. Okay, so it was pretty simple. When you started to collect all your variables on one side, the ends disappeared. And once they disappeared, you were left with 5 is greater than 8, which is a false statement. So just like we had when we were working with equations, if we lose our variables, then we either have no solution if it's false or infinite solutions if it's true. In this case, it was false, so there was no solution.